Hey everybody, Bobo had a question about a free Wi-Fi password, and basically he sent an email this morning that you all got, and it had a photo of this integral. And if you solve this integral, it said you get free Wi-Fi password. Bobo, in his email, rightfully noted that that differential element under the radical, the dx in the square root, just looked wrong. And yeah, I don't know what to make of it. So I think that is wrong. So what I think the correct integral is this one. And this is the integral you need to solve, rightfully, to get the Wi-Fi password. But I made the statement that you can solve this without doing any integration at all. And it's true, because there's a couple tricks. And so let's get started, and I'll show you. Well, you have to do a little bit of work. And the first thing you have to do is you have to take that square root and distribute it through the parentheses to get two terms. If you do that, you get these two terms right there. So what that essentially does is it makes two integrals. So let me show you what that looks like. I'm going to do this live. As you'll notice, I'm using a red marker and green cards, and I'm doing that because it's Christmas Eve, and I'm home recording this cooking sauce for tomorrow. So this is the set of integrals you have to solve. You have to solve two integrals now. What? Well, I said you don't have to do any work. So 2 times 0 is still 0. So that's what we're looking at. So let's take them one at a time. Let's look at that first one. Whoa, that's ugly, right? But there's a trick. And what is the trick? Well, the trick involves knowing something about even and odd functions. And let's talk about that. If you recall what an even function is. An even function is if you replace the operand, x in this case, with its negative x, you get the same value in the function. And it's written there in that line there, f of x equals f of minus x. That's analytically what it is. So maybe a little confusing, but geometrically what's going on is there's a symmetry around the y-axis. That is, you can reflect the function through the y-axis. Examples of this are y equals x squared, a simple parabola that goes through 0, and the cosine function. They both have even symmetry. Well, there's even symmetry, but of course there's also the odd symmetry. And the odd symmetry is a little more confusing analytically. You see that f of x is equal to minus f of minus x. Basically, if you negate the operand, you also negate the value of the function. That's still kind of special. There's a bit of symmetry there. And it's basically a symmetry about the origin. So you can rotate the function from the first to the fourth quadrant, sort of over, and you get that. Examples that are the cubic function, y equals x cubed, has this odd symmetry. And the sine function also has this odd symmetry. So you're saying, that's great, Joe. What do I do with that? What do I do with that? Well, so a special function, a special property of the odd function is this. That is, if you integrate an odd function about symmetric limits, you get 0. And this happens with an odd function. Well, why is that so cool? Well, as you notice, we do have symmetric limits. So if that being the case, if we can show that that function is odd, I think we're well on our way. Well, another thing about those types of functions, if you multiply them together, you multiply an even function by an even function, you get an even function. An odd function by an odd function, you get an even function. And an even by an odd, it becomes odd. Yeah, it's just kind of like multiplying integers. And in this case, you see, we can actually break this down, this integral down into 3 functions. X cubed, cosine 1/2 x, and the 4 minus x squared inside the square root radical. You see that? So we can do that. So essentially we have 3 functions there. We have the x cubed. We know that's odd. I already told you that. That was in the example. The cosine, that's even. That was in the other example. But what about this 4 minus x squared inside the radical? Well, the easiest way to do that is is just to replace the x by the minus x and see what you get. And if you do that, you get the same thing because the minus x is squared and you just get x squared again. So 4 minus x squared stays 4 minus x squared. So that's even too. I'm going to write that down. So we have an odd function times an even function times an even function. That gives us an odd function. And that's pretty cool because that means, what does that mean? It means something, right? It means that this is true for that integral. So what's that telling us is that that first integral is 0, and we don't have to worry about it. And that means we only have to worry about the other side, basically this integral. And we can solve this integral, and we get Bobo as password. Well, what is that function? Well, we already know it's not an even function, so we can't make it equal to 0. We know, so we're going to have to integrate it. But I said we're not going to do any integration, so I'm going to stand by that. We have to know a little bit about what that function is in there. Maybe you recognize it, maybe you don't. If you don't, let's do some algebra on it. See, there's the function in the first line. If I square both sides of that equation, I get something that looks like that. And then I rearrange it to get the third line. And if you're paying attention, you might recognize that as a circle of radius 2 centered at the origin. Pretty nice, right? Well, how's that help us? Well, if you think about it, we know how to calculate. An integral is just calculating the area under a curve. And we already know how to calculate the area of a circle. We learned that, I don't know, a long time ago. So we know how to do that. So solving this integral becomes pretty easy. Basically, well, let's draw it. I'm going to draw it right here. We're going to do this live. Here's a little x and y. Here's minus 2 plus 2. And over here, and there's a circle. And basically, we're looking at the top half of a circle between minus 2 and 2, and we want to find that area. We know what that area is. That's just half of the area of a circle, which is pi r squared over 2. And don't forget that 1/2 hanging out front. So to calculate the area, just looks like this. It's 1/2 times the area inside, times whatever the value inside the integral is, which is pi squared over 2. It looks like that. I left the brackets empty there because what's the radius? We said it's radius 2. Solving that is precisely pi. And Bobo guessed that right off the top. It's just pi. So you remember pi. So the password's something like 31459. That's all I remember it by. So maybe that's the password. I don't know. But there it is. I had heard about this some years ago. I didn't do all this work. This was just something I had seen the integral when Bobo put it up, and I remembered it. And that's what it is. So Merry Christmas, everyone. And I'll talk to you guys next week.